In October 2017, astronomers were just doing their usual routine, scanning the skies for near-Earth asteroids. Nothing out of the ordinary. Until suddenly, the sensors picked up something different. An unusual object was moving through the solar system, but its path was completely strange. It wasn't orbiting the sun like asteroids and comets normally do. It was moving straight across space, like it was simply passing by. This object was named Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. A name that couldn't be more fitting for what seemed to be the first interstellar visitor ever detected. Right from the start, Oumuamua shattered expectations. First, because of its insane speed, it entered the solar system traveling at about 196,000 miles per hour. To put that into perspective, this speed was so high that it couldn't be explained just by the sun's gravity. It was like it was already launched from somewhere else before even reaching our solar neighborhood. And that wasn't all. When astronomers analyzed its orbit, they realized it followed a perfect hyperbolic trajectory, meaning Oumuamua wasn't trapped by the sun's gravity, like planets and asteroids usually are. It was just passing through. It zipped in at high speed, felt a slight tug from the sun, and then kept on going, vanishing forever into interstellar space. But if you think that's where the story ends, think again. What really shook scientists was how weird this object behaved. It didn't look like a comet, it didn't act like an asteroid, and it didn't match any of the categories we knew. Something about it was completely outside the box. Where did this mysterious visitor come from? What exactly was it? And the most exciting question of all, what could it teach us about the universe beyond our solar system? That's how the race against time began, to observe as much as possible before Oumuamua slipped away into the endless dark. As Oumuamua moves away from the sun, the lighting changes dramatically. The intense sunlight no longer dominates the scene, but it's still strong enough to reveal an absurd amount of detail on the object's surface. The elongated body now appears, covered with deep, irregular fissures, as if it had been sculpted by countless collisions over millions of years. The cracks expose inner layers made of a lighter material that reflects the light with a faint metallic sheen. As it slowly spins, Oumuamua's surface reveals different zones. Some parts are completely smooth, almost polished, while others have sharp ridges and loose fragments. These rougher regions release small particles, grains of dust and tiny rocks, gently drifting away, pushed backward by a weak but constant pressure from solar radiation. The rotation is irregular, almost chaotic, with no clear axis. This tumbling motion highlights even more the extreme wear and tear it endured during its interstellar journey. The contrast between the illuminated areas and the deep shadows creates dramatic visuals. The cracks and craters seem even deeper, and a faint reddish glow from some fissures hints at the slow evaporation of trapped volatile materials. There are no signs of biological activity or technology, only inert matter, scarred by a history we still can't fully understand. Surrounding, Imi space is dotted with tiny fragments, forming a delicate and nearly invisible debris cloud. Each particle reflects sunlight faintly, creating a soft, barely perceptible halo around the traveler. Oumuamua now continues its journey out of the solar system, slowly disappearing into deep space, but not before leaving behind a display of details that defy any simple explanation. Oumuamua, the mysterious interstellar object that passed through our solar system in 2017, is still far from being fully understood. Since its discovery, scientists have encountered a series of unusual characteristics that have challenged traditional explanations for asteroids or comets. Its eccentric trajectory, unexplained acceleration, and peculiar appearance have sparked a wave of speculation and investigation, yet it remains an enigma to this day. One of the most intriguing questions that arose was Oumuamua's acceleration. Unlike comets, which release gases and dust as they approach the sun, Oumuamua did not display a visible tail. This led the scientific community to reconsider traditional theories. Some suggested that the acceleration could be caused by a of solar radiation pressure, a known phenomenon, but one that is usually not capable of generating significant acceleration. However, Oumuamua seemed to move in an unexpected way, and the usual explanations simply didn't apply. The theory that sunlight striking the object's surface exerted enough pressure to push it along became a plausible hypothesis. However, the efficiency of this process depends on various factors, such as the object's composition and shape. The fact that Oumuamua had an elongated shape, estimated to be 10 times as long as it was wide, added another layer of mystery to the case. This is completely out of the ordinary. It doesn't resemble any known asteroids, which are usually spherical or irregularly shaped. This not only challenges our understanding of how celestial bodies form, but also might be a factor contributing to the observed acceleration. The theory that it could be a fragment of an asteroid or comet became increasingly difficult to support, given its anomalous behavior. Instead of being a spherical or irregular rock, Oumuamua appeared to be a kind of cosmic cylinder, a long and angular structure that could have formed in a very different way from conventional asteroids. In addition, the composition of the object generated debates. Studies of its luminosity and spectrum indicated that it could be composed of rare metals, substances commonly found in some meteorites, but extremely rare in objects traveling through interstellar space. This led scientists to suggest that Oumuamua could be a fragment of a distant planet or even a star. Some even began to speculate that it might be a probe sent by an extraterrestrial civilization, an idea that, though highly speculative, cannot be entirely dismissed. Given its anomalous behavior and unexplained acceleration, this theory gained popularity among some scientists, though the majority of the astronomical community considers it unlikely. The object's shape also led to a range of hypotheses. Its seemingly smooth surface and its irregular brightness fluctuations could be a reflection of a highly polished metallic structure, which would be consistent with the idea that Oumuamua might be an interstellar probe. The fact that it accelerated unexpectedly as it moved away from the sun is another intriguing point that could suggest it wasn't simply a fragment of rock, but might have some sort of propulsion mechanism. Some scientists propose that the acceleration could be explained by a highly efficient solar radiation pressure system, which could be used by an alien probe. Beyond the possible explanations for the acceleration, observations of its radiation emission also indicated unusual behavior. When Oumuamua passed through the solar system, it appeared to emit radiation or particles in a manner very different from other interstellar objects that had been observed until then. This led some researchers to raise the possibility that it could be interacting with the solar environment in a way that is still unknown. The idea that it might be some sort of vehicle with advanced technology wasn't entirely dismissed. In fact, one of the most fascinating questions raised was the absence of a gas tail, which is common in comets, but the observed acceleration is more typical of an object with advanced structural or technological features. Despite the investigations and the numerous hypotheses that have emerged, there is still no concrete explanation that resolves all the mysteries surrounding Oumuamua. Many scientists continue to study the object for additional clues, while others question whether we will ever be able to fully understand what Oumuamua really is. Its behavior, shape, and composition challenge the laws of physics as we know them, and by doing so, force us to rethink what we know about the origins and evolution of objects in the universe. What is certain is that Oumuamua, whether it is a fragment of a distant star, an alien probe, or a rare natural phenomenon, has become one of the most important and intriguing discoveries in modern astronomy. It has opened new doors for the study of interstellar objects and, perhaps, has shown us that the universe has much more to offer than we are capable of comprehending. The mystery of Oumuamua still lingers, but its passage through our solar system has already left a profound mark on space exploration and on the way we understand the cosmos. Oumuamua wasn't just an enigmatic visitor. It quietly sparked a revolution within the scientific community. Before its passage, the idea of interstellar objects wandering between stars was more theoretical than real. But Oumuamua forced a major rethink. If it managed to pass through, how many others have slipped by unnoticed? That question lit a fire under proposals for new space missions. One of the boldest ideas is Project Lyra, which is exploring ways to launch a probe capable of intercepting interstellar objects in the future. The concept involves building ultra-fast spacecraft that could leave Earth within weeks of detection and catch up to these visitors before they vanish into deep space. This shift in mindset also forced astronomers to rethink their own classification systems. Before Oumuamua, there was no official category for interstellar bodies. Now, in addition to traditional asteroids and comets, there's a new type: interstellar objects, a classification for bodies that don't belong to our solar system. This new category pushed astronomers to create specific protocols for observing, analyzing, and cataloging such objects, making sure we're ready the next time one shows up. Perhaps the most practical transformation happened in how we monitor the skies. The discovery of Oumuamua was almost accidental, and its unusual speed and trajectory made it clear that our sky survey systems needed an upgrade. Since then, projects have been launched to build networks of automated telescopes powered by artificial intelligence, designed to spot anomalies in motion patterns. The upcoming Vera Rubin Observatory, for example, will play a key role, with its wide-field telescope mapping the sky almost continuously, dramatically boosting our chances of detecting future interstellar travelers in time to study them up close. If Oumuamua taught us anything, it's that the universe is full of surprises, and we've barely scratched the surface. New discoveries could be lurking just beyond our sight, waiting for the right moment and the right eyes to be seen. Stay tuned, because the next visitor might already be on its way, and this time we'll be ready.